Okay, you might be asking, how do I make schematics and circuit boards? So I thought I'd just kind of give you a general overview of how that works. Um, this is a software that this is software that I use for designing circuit boards called DesignWorks. However, it's kind of obsolete. I haven't updated my operating system yet because it won't work with this software won't work with the most current version of Mac OS. So I'm planning to upgrade pretty soon anyway, and I'll probably get a license for some other software. The other software does both the schematics, which are the diagrams or drawings for the electronic circuit or electrical circuit if you're doing that. And another piece of software that I use is a program called Osmond. Let me find Osmond here. And Osmond does circuit boards. But we're not going to do that yet. What I'm going to do is kind of just give you a overview of how this works first. First thing we do is we design a circuit. In my library of parts here, there's some parts I make myself and some parts that are just part of the library. Discrete components are things like resistors, transistors, capacitors. I'll just go through this kind of quick. I want to make this a short video. Connectors, things where you'd plug into the circuit board. These are some connectors, male connectors. This is a ground symbol, transistor, resistor, capacitor, more resistors. Anyway, I'm using the existing library of parts just for this little demo circuit. Sometimes if a part doesn't exist in this library, I have to actually make it or draw it myself. I won't load that in there. There are quite a few parts in here, but like I said, not always everything that you would need or want, so sometimes you have to make your own part. And the way you would do that is you would go into the one that says, let's see, not circuit library, where is it? Give me a second here. Let's see, you can do okay, no, we'll get into that yet. Let's see, device editor, I'm sorry. Go into device editor, use these things. These represent pins facing in different directions. This is to add text to your diagram. So let's say I needed a particular chip that doesn't exist in here. I can go in here and I can make a square or rectangle shape for this particular chip that I need. Just make a square, add the pins to it. This would be pin 1, pin 2, pin 3, pin 4, pin 5. If I want to put pins on the bottom, I could go with this here, but I won't do that. There's a lot of chips aren't, well, some are, but it depends what you're doing. Pin 6, pin 7, pin 8, pin 9, and pin 10. And then once I'm done with that, I can double click on the pin numbers. I can change it. It has a name. It doesn't have a number yet. That number is important. So if I want to call this pin connector 1 or signal 1 or whatever I want to call it, I can call it that. But it's important that I assign a number to it because this software, DesignWorks, is going to generate a file, a text file, that it's going to send to the circuit board software I use called Osmond. I generate what's called a netlist, and all those pin numbers have to match the part that I have in Osmond. Otherwise, the signals will all be misconnected. So we're going to do pin 1. We could enter pin 2, hit tab, go to tab, go to 3. I'm not going to do all of these because this part we're not going to use. But just so you'll see, and it puts the pin numbers on them, and it will go in the order that I have in this list here. So that's a part. It's going to ask if I want to save it. No, I don't want to save any changes to that. So we've got this schematic drawn already. If I want to, I'll just show you how that would happen real quick. Then we'll go on to the circuit board. Let's say I want to add a resistor to this circuit. I can go in here to resistor. RES would be the abbreviation for that. This is a resistor. Click on that. Double click on that. I've actually double clicked down here. I'm sorry. Then drag it over to the circuit. Put it where I want. If I'm not happy with the orientation of it being, say, horizontal, I can flip it around. vertically. If it had a pin 1 and a pin 2, say top and bottom, I could flip it around so pin 1 would be on the bottom rather than the top, or however I want it, change the orientation of it. Now hit the escape key, get out of that. We don't want to add anything to the circuit. Let's assume that this is a real circuit. I just put some parts in here and some random values. This circuit may or may not work. It's unproven. What the point of this was just to show you how the circuits are done. I add text to it so I know that this is going to be plus 15 volts. This is my ground. The ground is actually considered, since all the grounds are connected together virtually, well, on the drawing it's virtually, but on the circuit board, they're physically connected together. And you have what they call pseudo PCB devices. In this case, this is the ground symbol that I have here. As you can see, I'm going to get rid of that. Don't need any more of those. So now let's move on to the circuit board. So I would take this, I would generate a netlist. And the netlist here, which is doing, it actually has a listing of the pins, what they connect to. And then I have to go into Osmond down here. You find Osmond right here. Go into Osmond. Now what I'm going to do at this point is I'm going to import the part and netlist. So we go to that. That's in the DesignWorks folder. Click on that. Come on here. So we're going to do DesignWorks. Just opening up DesignWorks to show. Okay, that's just slow. So I go down here and there are some files with the extension .pcb. Everything else is grayed out because Osmond doesn't recognize what those are. So we go up here to demo. Where's it at? Should be demo. Let's see, I hope I didn't save it in Oz. No, I should have saved it here. No, let me just check, make sure that I didn't put it in the Osmond library. It shouldn't have. I think I have everything saved and it's in DesignWorks stuff saved in DesignWorks folder, but let's just double check. No, don't see it. Let me try this again. Let's go back to DesignWorks real quick. Do another netlist. Let me hide Osmond. Osmond, generate netlist. Just doing it again. Now I go into Osmond. Where's Osmond at? Here we go. We're going to import the part and netlist. Should have one titled or named demo, and that should be in the DesignWorks folder. Right there. Takes a minute. My computer runs a little slow, probably because it's doing video also, and this is a older laptop as well. So go down here, look for that circuit again. It should say demo.pcb is what it should be titled. Scroll down a bit. We're almost there. Let me do a search for it then. Because it's not showing up here. I don't know why. Wouldn't normally otherwise, but maybe because I'm doing a video. Demo.pcb. Yeah, it should have been dot. Let's go to DesignWorks for demo. Name matches demo. Okay, not finding anything. Let's cancel that. I want to make this a short video, so let's try to find it here. It's a little sluggish. Normally these windows pop up right away, but it's not doing that. Should be demo.pcb. There we go. Where is that located? It's on the desktop. Oh, okay. That was my mistake because I did put this file on the circuit file on the desktop, and it saved the demo circuit board in the same location. So my mistake with that. Okay, makes sense. I was wondering why it wasn't showing up. Now go here, go back into Osmond. So I guess that's a lesson. So if you we're going to import. So if you do make a circuit, be sure you have your folders organized. This is a place I normally wouldn't put that, but just because I'm doing this demo video, we are going to do that. And so now it's giving me an error message. Sometimes if something doesn't match up with the part, and we'll look at that. Let's see what's going on here. Okay, so probably what happened is the part, okay, and that's something I should show you. This would something, when you make these parts, or when you put these parts in the circuit board, you don't just simply grab them and put them there. They have attributes, and I forgot to mention that. You can give it a name, in this case R2 for the resistor 2. What's important is where it says PCB part, these numbers. This is the actual package or drawing that Osmond will call up to know the shape of that. I'll have to show you that too on the circuit board. But what it's telling me it's having a problem with is a part that is one of these connectors. Something that should say 2TH100M. So it's a name I made up. 2 pins through hole, 100 mils or 0.1 inches or 2.54 millimeters apart. So one of these doesn't have the M, I think, on the end of it. And that's why it's giving me an error. This one right here, this says 2TH100. So Osmond is compliant. If I control click on that, or I guess if you're using Windows, it would be like a right click. I have to add the M on the end of it. So now when I do this, I'm going to go up here, make a netlist for Osmond. This software does it for various other software, Douglas, PCB, MaxSpice, Osmond, or generic PCBs. Make the netlist again. This time when I import it into Osmond, it should be fine. That was the only complaint that it seemed to have. Fortunately, this is a very simple little drawing I made. Nothing really complex, because if you do have something that's really complicated, you might end up going through it. If you have a lot of things you kind of made mistakes on, things you forgot to specify. Now I'd imported it with no messages, with no error messages. We go into Window. We're going to go to where it says Deferred Parts. Library shows all the parts I have, and I imported quite a few of them just to be sure I have the right ones present. And there's a lot of them, but we don't need that. We only want the deferred parts, which are the parts specifically for this circuit board that we are going to use. They're deferred because they're not on the circuit board. So this is one of the connectors. I grab it, draw it, drag it, put it on the circuit board. I can take the next one, drag it, put it on the circuit board. And right now I'm just dragging all the parts to the circuit board. And then what we're going to do, and I'll show you that in just a second, it only takes a few more seconds to get the rest of these parts because this is a really simple circuit. And as you can see, these parts are very small. And like I said, we're going to go through this and I'll show you the whole little process. I'm going to try to do it kind of quickly. Now you might be thinking, okay, you got the parts on the board, how do these things all connect together? Well, I could go back and I could look at two things I could do. First, I could go back and look at the schematic, and I can look at these parts and I can say, well, what's connected to what? I know this transistor is Q1, so, and I know at the top here, this resistor is R1. Let's say this resistor is R4. So I could go here and do that. I need to turn this around, I think. Rotate this, by the way, does turn it around. Let's do this. I'm going to show you something else in a second here. But if I click on Join and I click on one of these pins, it will show me what other things are connected to that particular pin on this transistor. And they're red. So what I need to do is take these. I'm probably going to flip them around too, so that when I drag them over into the right place, they are going to be in the right position on the circuit board. So let's do this. We'll put this capacitor here since it connects. I want to make the screen a little bigger, and I'm actually going to move this back up. We're going to change the grid size. So if we want things to be aligned to a particular uh, position on the grid or certain spacing, we can do that. We can do in mils. A mil is a thousandth of an inch. So 25 mils, 25 thousandths, or 0.025 inches. 100 mils is a tenth of an inch, 0.100. I could do it in millimeters. I could even make custom grid sizes if I need to, but we're not going to do it. We'll go with 25. Make this, blow this up a little bigger, and line this up a little better maybe. Maybe drag it down a hair, I don't know. Maybe that's kind of in line with that. Or the parts, you can actually go in here and you can actually have a thing that says snap to grid right here. So when you drag a part on here, it'll try to line it up with one of these spaces. What we would normally do is go to join. If I want to connect those together, I can do that. It's going to draw this thin line. It's basically like a wire. But let's say I want to see how it's actually going to look on the circuit board. I can go to the one that says full width traces, and this is going to actually draw the actual size of that, actual width of that, which I think is 5 mils wide. That will be the thickness of it on the circuit board. This is how it's physically going to be laid out on the circuit board. Let's try to do this kind of quickly here. Let's grab the other parts that we were missing. Let's do this. I can grab both of these together and drag them over into the same area. Let's try to center this a little better. R2, R3. Let's look on the schematic and see where those are. Okay. R2 and R3. R3 I didn't. Okay, let's change the attributes on that. This is R3, and it's not showing if I control click or right click if you're using Windows on this. I can go to where it says name, and then that says default visibility, which is basically invisible. Click on always visible. Now R3 will pop up over here. I can drag those around as well. If I don't want the R3 there, I can drag it over here or whatever. Same thing with this one. We're going to click on that, change the visibility of it so we can see it, see what parts actually, how they're laid out, because and actually in this case, the parts are going to be laid out physically similar to the way that they're drawn on here. That's not always the case, but in this case, we're going to do that. R2 and R3 is going to be at the bottom. So let's drag R2 here, line it up with this. These are still connected or highlighted, so take R3, I got to flip it around, then I'm going to drag it to, actually what I want to do this a little different, because even though this is connected to here, so is R3. And what I need to do, since this is a voltage divider circuit, let me see something here. Let me find out. There's going to be another 2 resistors because of the voltage divider circuit. So R1, R4. Let's see, R4, what pin is that? R4 is going to be our emitter, so just, oh, okay, never mind. I actually need to flip that around this way then. That's the base of the transistor, okay. I'm going to rotate this transistor like that. Get out of turn, because I don't want to click on anything accidentally and turn it around. So we're going to go back to join, and we're going to take these resistors to move them, not join, I'm sorry. Select, I've got to drag them into the right positions. Put this here. I do want to go on join again because now it's showing the other things, other signals. These do come up if I click on it here. If you look at if I move off of it, you won't see it. But if you look on this particular window, at the top left corner, it says R2-1 signal 3, or sig 3. So this is resistor 2, pin 1, and this whole connection here, here, and here are signal 3. Net file, I was talking about that netlist file, is actually what has all that information in it. So now we've got those in the right positions. We can physically join them together like that. So now let's move on to the next part, which is going to be this resistor here, which is going to go to ground on the other side. I got rotated too much. Yeah. Okay, R4, going to go to ground. Same thing with this other one. I'm going to move it a little bit away from that one. Doesn't have to be, you can arrange it however you want, whatever spacing you have on your circuit board or whatever that's connected. These two are going to go to ground. And I'll show you a little trick here. What we're going to do is let's click on the ground side of these. These are all red. These are going to be connected to ground. I'm making a 2-layer circuit board. I can make 6, 12, 8, however many layers I want. But understand that when you start adding layers to a circuit board, the cost starts going up exponentially. It might go from one price, it might go to triple the price or 4 times the price. I don't know the exact amount, but what we want to do, we'll just use the second layer of this board as a ground plane. In other words, I'm going to go to that second layer. I can click on it here, or I can hit the number 2 on my keyboard, and we're now on layer 2. On this case, that's going to be the bottom side of the circuit board. A lot of the boards I design are 4 or 6 layers or whatnot. We can do, let's say that this whole bottom side, let's suppose I want to make it all copper. So everything on the bottom of this, unless it's some type of trace that's isolated, the trace is like a wire. I can go to, let me see here. I got to go to where it says make, where are we at? Copper flood. If I go to copper flood, there we go. The color's right this time. Some of them I've had to change it because it didn't show up. This whole bottom side of the circuit board that's blue is all going to be a copper surface. So we'll go back to the top layer, hit layer 1, go to the top. We're going to add a via to this signal. Up here is a via. If I double click on it, I can choose different size vias. I can make my own. I don't have to just stick with these, but these are ones I already made. And I can tell it to make that via pass through. A via is basically a copper plated hole. There are different types of vias. This is just the regular via, and I'll explain the other ones in just a second. And it will pass through all of the layers from top to bottom. And that's what we want in this case. We're going to add this via here to this layer. And then what I'm going to do, well, let me explain the vias first. You can have what's called, this is just a regular via, you can have what's called a blind via. Let's say this board has 4 layers, 1, 2, 3, 4, and I want to make a via that only goes from layer 2 to layer 3. Doesn't pass through the whole circuit board. That's called a blind via. It's blind because you can't see the top of it and you can't see the bottom of it. It's blind to you. It's like invisible. Then you also have a filled via where the via is actually filled in with some material. And I'm trying to think of this another one, basically where it would, oh, I'm sorry. I made a mistake on that. Blind via would be one that might pass through the top board of the board and maybe it doesn't go to the bottom. So if you were to think of a via as like a tube or a pipe, if you were to look through it, one end of it's blocked. A buried via, on the other hand, is one that might be in between layers. It might not come to the top or the bottom of the board. It might literally be buried between layers. And let me explain that. Okay, so now we've got this via. Let me connect this to here and here. What we're going to do, since we want to connect all the things that are grounded together, we'll go to layer 2. I'm going to make a surround. If I double click on that, what it does is around that hole, these sides that are darkened are going to be connected to the ground layer. I want to do all 4. I usually like to have a really good ground when I do things, unless I have a wire passing across one side or something, then I might unselect one of these, or I could select all of them if I want. If I want to make this whole thing all around, in fact, you know what, this is next little thing here. I'll show you the difference. If I just do it like that, 4 parts of this hole, this via will be connected to this ground surface. Do that, we'll click on it, and you'll see the 4, 1, 2, 3, 4. Let's go back up there, and let's say I want the whole thing. I want a really good ground. I want to make sure that that's connected to this copper surface on the bottom. Do that, and the whole thing will be connected. All of those will be connected to basically the whole thing is connected to this surface here. So now we have a ground plane. That's where, like, our negative of our power, or one side of, let's say, the output. If it's going directly to a speaker, since this was an amplifier circuit, one side would be going there. These are some signals that are coming in. I generally would turn it like this, pin 1 towards the top a lot of times. On my circuit diagram, I make a little arrow that points to pin 1. On my capacitor, this is the positive side, this is the negative side of this electrolytic capacitor. It is polarized. This one here is going to be the same thing. I'm going to rotate that around. So what we can do here in this case, let's do this first, and then what I'll show you. We'll go back to this in a moment for a reason. This is going to be our incoming power for this. I just put it up here for this amplifier. This would be what we connect our 15 volts. I can have it go straight there, but let's say something was in the way and I want to route that around it. I go to quick route and I can physically click on that signal and I can drag it wherever I want to go. And this software does that. More advanced software will do some of these things, help you do that. This software, you have to manually route everything yourself. What's the difference? This software, this and Osmond, between the two of them, I think I paid less than $400 for them. If I had some nice expensive software that does all these signal calculations for high-speed signals, something like Altium Designer, that cost, it's expensive. It's an annual license, meaning you don't just buy it, you pay for it every year. And Altium Designer costs you $7,000 per year. $7,000 per year. If you are in the Philippines and you're wondering what that is in Filipino pesos, right now the current exchange rate, I think, is like around 38 pesos to $1. So if you were to say 7,000 times 38, it would cost, the Altium Designer, the really expensive fancy software, would cost you 266,000 pesos per year. Like I said, annual license, meaning every year you pay for it. It comes with all support and update and everything, but that versus $400 is a big difference. I'm going to upgrade to something else that's a little more than this, but also not as expensive as Altium, but it will do a lot of the things I need. And that's going to probably be Eagle CAD. So I may be switching to that soon because, like I said, this software here, DesignWorks, they just decided to stop making it. Didn't give anybody any warning or anything. Just you can't get it from their website or anything. There are no updates. It's getting kind of old. It's served its purpose for me very well. It's been a good piece of software. It's got its quirks, for sure. Anyway, let's get back to this and try to finish this up. I'm going to find out what other signals we've got. That's going to be coming off of this capacitor here. I know, and so now I know where my signals are going because that's going to be an output. And I'll explain to you a little more detail about how this is supposed to be looking or working. We're going to put this here. We're going to put this one here, since I know it, I just know already that's where it's going to connect. This resistor has to go up there as well. This is the, okay. So I'm going to rotate that around, drag it over here, so we can finish up this circuit. And I can put that resistor here. And as I was saying, if let's say I want to move the name of that resistor over, I can drag that as well. So R1 on that side. Maybe I want to put this resistor up a little higher and out of the way. So I'll just do that. Now I'm going to connect it, use join, go from there, drag from there to there, go from there to there. Let's do this while I'm at it. This one as well. I know it's going to be the power. I can drag it there. I don't have to put it there. If I want, let's say I want to move this connection from here to down here, I can do that. I can go to quick route. I can drag it down here and I'll do that. But that's probably not a good place to put that because it's kind of close to the other pin. I don't want those to short together. So we'll just put this back where it was. When I click on it, it sticks to wherever I clicked as I'm dragging it around. So this circuit is almost complete. What do we need more? What more do we need, my brother? Let's see. Let's connect to the, that's the ground, and there's another connector here. Let me zoom out. Oh, there it is. Okay. This would have been the incoming signal. Let me rotate that around. We'll zoom back in a second as soon as I get that a little closer to this. I'm going to put this here. This circuit is just a real simple little amplifier. Hasn't been tested. I can't say this circuit's going to work. I just chose some random values just to show how the circuit board is done. Okay, now these here, I'm going to go on these. I know the bottom of each of these connectors is connected to ground. Remember, ground, if I go to number 2, layer 2, I just click on the 2 button on the keyboard. This is my ground plane. What I want to do is I'm going to click on join. So now we've got all those signals highlighted that need to be connected together. This is the only one that's connected to ground so far. If I go back to the surrounds again, and let's say I want to connect all of those, whatever, how I want to do it, for 4 points on these hole or these pads. Because when it comes through the circuit board, this is a through-hole part, meaning a through-hole part is one that actually has a hole in the circuit board and it fits in a hole in the circuit board. Surface mount parts, as you'll see with these capacitors, have just pads on the top layer of the circuit board. There are no holes in the circuit board, so these parts sit on top and they're soldered to the top surface of the circuit board. These connectors are all through-hole parts, meaning they have 2 metal pins that go through the circuit board and pass all the way through to the bottom. So I'm going to go back to the bottom of the circuit board, and I'm going to use the surround, and I'm going to connect each of these pins on these pads. As you notice, they change colors, and when they're all blue, that means they're connected. So if I forgot something, it should be highlighted red. Everything should be connected now. Now, there's a few things you would also want to do. Let me go to select and get out of that so I don't actually click on something inadvertently. What Osmond will do is you can go to what says check all layers, or you can check the current layer, but we want to check the layers. There's only 2, the top and the bottom. And what it would do is it'll do some checks and see if there's anything wrong. That highlights on checks. No error messages came up, so it didn't find anything like if these, let's say these were too close together, it might give you a warning. You can go into here and you can make what are called design rules, where you actually, let's see, that's actually should have been, let me find it, not there, but there's a area here where you can enter design rules, design options, that's what it is, and you can specify a minimum spacing for, yeah, the outer layer spacings, because sometimes the outer layer and inner layers may have different size spacings. This is 10 mils, so these signals should be no closer than 0.010 inches apart, which is 10 mils. A mil, like I said, a mil is a thousandth of an inch. If I want to convert that to millimeters, so you know, this would be, these signals should be no closer than 0.254 millimeters. If they get any closer, Osmond will generate warnings and saying that, yeah, these signals might be too close and possibly short together. I can specify the number of layers. In this case, I already did that, so I can't change it. This working area is the height and width of this board, but I'm going to show you that's not too relevant at the moment because what we do, I jumped around, I did that. We got the circuit board. Let's say, all right, on how, okay, I got a big circuit on it, but it was showing a 12-inch by 12-inch board, but this doesn't take up that much space. So what do? How does the circuit board house know what we want, the shape of this board? What we do is we generate another layer. Everything's connected. Well, before we do that, go back to design. I want to show you. We did the check all layers. What we want to do is check all connections. Let's say you had a complex circuit and you had a lot of things that are connected together, and you want to be sure you connected everything. You go check all connections. It'll check, and if you miss something, it will tell you. In this case, it says no connection problems found. This is a simple circuit. Not much has to be connected together. But now we want to make the shape or the outline of this circuit board so that when we have this board made, we want to have a shape for it. So we go to the auxiliary layer. That's what this A1 and A2 are for. We're going to talk about the soak layer in a minute. So let's say we go to the draw tool and let's make this, let's change the grid space now, change it to 100 mils. So these are 10 mils, or not 10 mils, I'm sorry. This is 0.1, 0.2, 0.3, 0.4 inches, or each one of these from here to here is 100 mils, another 100 mils from there to there. 10 of these, of course, makes up an inch, so this is 2 inches so far. This would be about, I'm sorry, 2 inches rather, from here to here. We're going to add another ½ inch out here, so that gives us 2.5, and say another ½ inch on this side, so it gives us 3 all inches altogether. But we don't want this connector right up against this line here, so let's go 1/10 of an inch away from here, and this one we're fine. So what we do is on the auxiliary layer, we're going to use the draw tool, and we're actually going to draw an outline for this circuit board. So when the circuit board house makes this, they will know that this is the shape that they need to cut this circuit board to. 2, 3, 4, 5, it's about ½ an inch there. We're going to go down, we can go down to this line here. We could make other shapes, we could draw it different ways, but in this case we're just going to make this a square or rectangular shaped circuit board. We're going to go another ½ inch just to be on the safe side. Go up here. So now this board is this is 1 inch, and this is 1/10 of an inch, so this is 1 1/10 of an inch, or 1.1 inches by, what I say, 2, that's 2, so it's about 3 inches altogether from here to here. Let me think, 3 inches is going to be 5.4 per inch, so 50.8 for 2 inches. Oh, plus another 25.4, what am I thinking? Okay, so 76.2 inches, millimeters. Yes, I think that's right. 76.2 millimeters. This is going to be 25.4 plus another 1/10 of that for 27.9. So anyway, about 28 millimeters from here to here. And I forget what I said, 70 something, 75, 76 millimeters from here to here. Just in case you're dealing with metrics. Okay, so we're on this auxiliary layer. Let's get off of that. Let's get out of the draw. Go back to select. Go back to our first layer, and you say, oh, okay, great. This is circuit's finished. Oops, we made a mistake. I forgot that. Yeah. So now I got to go back here. Got to go to cut. We're going to cut that out there, and we're going to make this board a little wider now. We're going to draw, and we're going to come down a little bit more, because I forgot that via was there because it doesn't appear. That's one of the problems kind of with the software, because it doesn't, when you're on this layer, a lot of things disappear. It should make it like in shadow or something so that you can see it a little bit, but it doesn't. Like I said, it's not real expensive software for what it is, but it's also not too bad for, considering what it does for the price. So now we got that via in there. Otherwise, that would have been chopped off of our circuit board if it went down to here. Now, okay, nothing is on here. There's no labels on here. What do these things connect to? What do they do? This is where the silk layer comes in. We're going to go to silk layer 1. Silk layer 2 might be, for example, let's say we want to put some text on the bottom of the circuit board. They call it a silk layer because they silk screen the text on here. We have a text tool. We go here. we're going to say plus 15 volts because I know that's what that's supposed to be. And I don't want it to be that big, 50 mils in height. I'll make it is what I want, but not 100. So I'm going to go here, and I'm going to put this right about, let me change the grid space in here. Maybe it'll snap to that. Let me zoom in some more too, so the grid spacing actually shows up. So I'm going to put that text right about here. I'll about to drag it, grab that text, drag it into the right position where I want it, plus 15 volts. We're going to do another one for ground. G and D, initials for ground. Put that right about there. We drag it, and if I want to make it a little more what I think is centered with that pen, I might do that. So now we've got plus 15 volts in ground. That's our power connection. If we look at the top of the board, That's where our power comes in. There's incoming signal. I'll just put in and I'll put out. If this is an amplifier, so just imagine you're plugging in, like say, well, a guitar would need a preamp, but let's say you're plugging in a musical instrument, or you're plugging in a microphone or whatever will go to your input. Like I said, just an example. This circuit may not actually work. I just threw it together just to explain how they actually go ahead and put another ground here, just so that whoever this person is, our imaginary person uses it, they wonder, hey, how do I connect everything? They'll know. This is how the signals are connected. We'll go up here and we're going to say in because this is our signal input. So we'll just put in for that. And we're almost done with the circuit board. We're going to put this here. We're going to drag it into position, what we think is just about right. And then we're going to go over here to the output of this amplifier, and I'll move this. Let me see if I can, yeah, I'll move this here. Let's put that there, and we'll put the text on the right side there. So now we're going to have ground again, or in this case we're going to have out, I guess, first. So I'll do out, put it there, put it on the circuit board. Okay, we drag it and center it a little better than that. Maybe I want it right there. Maybe I don't want it that close. Maybe that's good. And then ground again. And we'll do that. Put that. And we'll do that. And let's say, okay, we got that. But let's say you want to, you're whatever, a manufacturer. And you say, oh, I want to put my name on this circuit board to identify it, or some model number. Let's give it a model. Let's call it demo circuit amplifier circuit. I could put for the demo amplifier circuit for just the demo amplifier circuit. Let's make the text a little bigger. Let's make it 75 mils, so it's going to be bigger than the other text. And I put that right about here. Now I got to drag it over. If the text is too big, we'd have to make it smaller. It fits right about there. That's kind of good. I'll just put another one here. I put my name or something here. But I'll put by Mark S. Lewis. Mark Lewis. That's my middle initial. I just say that because some people have thought my name was Marcus, and I'm like, oh, it's Mark, not Marcus. I think that text is too big. I want to make that, so okay, let's make it 50 instead of 75. And I'll just put it here. So you got that. Yeah, like you see this circuit, what type of circuit it is, or what it's called, and the designer's name or whatever. So that's how that would work. Go back to the first layer. So now we got a circuit board. Let's zoom out a little bit so we can actually see the whole thing on screen. You say, okay, let's move this over a little bit. I see that's kind of close to that. I don't want that like that. Let's go back to the silk screen layer. Click on that. Drag it over a hair. It's close to the edge of the board now, but that's fine. I just don't want it on or overlapping a pad for this resistor. These little contact surfaces on the top of these circuit board, those are pads. The lines are called tracks or traces. I used to say traces. Some people call them tracks. But most of these are surface mount parts, with the exception of the connectors, the through hole parts. And as I was saying before, a through hole means that it's actually got metal pins that go through the entire circuit board, top to bottom. Whereas surface mount parts just sit on the top of the circuit board. So this circuit is more or less complete. Then let's say, well, you say, well, okay, well, you got that complete. Now, how does the circuit board house get this board, and how do they know how to make it? We've got our outline on the auxiliary layer. We have our text on silk screen layer 1. You could put text, and we'll actually do that on the top or the bottom of the circuit board, but you don't want to do that because what happens is this doesn't get silk screened on there. It actually ends up as being copper. Like these traces would be copper. And then when they put the solder mask, which is the color over it, like the circuit boards are green or blue or white or red, that would be over the copper that has this text. So you want to put it as a silk screen. And then usually you can specify, most of the time it's white text. So they use white ink so it stands out um, on the circuit board. Some cases, some places might have others, but uh, in general, unless you're making a white circuit board, the white ink stands out best and you can actually read things. And clarity is important because when you start getting to really, really small parts, these aren't the smallest parts that you can get. You can get some parts actually much smaller, and it would be hard to read the text. In general, one of the rules is you don't want the text to be smaller than, they say 50 mils. I would say 35 because I think these labels for the resistors are 1 or 2. I think they're about 35 or 3 or 4, and they're still readable when you get the circuit board. So I'd say 35 mils is probably about the smallest you'd want to go as far as the text size. The other software is going to be different than this, but I'm using Osmond, and this is the general principle is the same as it is, although like I said, other software is much more complicated than this and will do some other things that Osmond doesn't do. When I upgrade, maybe I'll eventually show you those things. Osmond's simple, DesignWorks is simple, and so, oh, my video's still going. Anyway, I just want to keep it, just use some simple things here, just so people would understand. Anyway, making the files, after this is done, you're going to export it. I need to save it because that's grayed out. So I'll go to Osmond, I will just save, I could just do it from the keyboard, but I'll save it. Now this has been saved, what it's going to do, it's going to say, okay, Gerber files. What it's going to do is going to generate these files, and maybe I'll try to show those. Maybe I should make that in another video. Maybe I will, because this is going to be kind of long. And it will generate some files, and they're going to be in a folder, and you'd send those files, you'd zip them up, compress them, and you'd send that through the website or email or however the circuit board house wants them, and it will give them all of this, and they will know how to make these circuit boards. Often they do them in batches. Sometimes they might say a minimum order of 5, and it could be as cheap, depending upon where you go, as cheap as for like a 2-layer board, 5 of them for like $4 or $2 or whatever. Just depends. Sometimes they have specials, but even at 40 cents to $1 a piece, that's really super cheap. Now, when you start getting to multi-layer boards that are like, 4 or 6 layers, the price goes up. You might go from $2 to $8 to like $60, or depending upon the size of the board, the price also is going to jump exponentially too. So you might design a board that's maybe twice as wide as this and has 6 layers. Instead of paying $2 or $4 for this board, you might end up paying $60 or something like that. And then if you get even bigger, you might end up paying like 100 and something for it. Anyway, I'm going to end this, and that's how this is done. See if I can, there we go, in the video.